Welcome everyone. Today is December 9th, and this is another of our bi-weekly SIG Apps call. My name is Maciej, and I'll be your host today. We have two topics for today. The first one is announcement. We will be migrating our Kubernetes SIG Apps mailing list. Currently, all the groups exist on the Kubernetes on the Google groups. The interface will not change, only the address will change. So instead of Kubernetes-SIG-apps at googlegroups.com, we will be switching over to SIG-apps at Kubernetes.io. The interface will be the same. Users don't have to do anything with regard to this change because we will be migrating all the active users automatically to the new mailing list. We will continue using both of the mailing list until the end of 2024 by cross-posting to both the lists. But all of our documents, all of our references will be slowly switching over to the new mailing list so that people get used to using the new mailing list. I'll make sure that the invites are also updated. All the links in the community repos, in the agenda, and everywhere else where I can find that we have a link to the mailing list, I'll make sure it is announced. I'll also send an email after I'm done with the migration that everyone has been migrated in case, and we'll send to both lists in parallel to make sure that people can verify they are correctly migrated, because at least the ones that I know that are not active, those will be skipped in the migration, because that's what I've been doing in the past with the other SIGs that went through the process. The benefit for everyone of us is that the SIG Apps at Kubernetes.io Google group falls under our Kubernetes Google account, which allows us to have a smooth migration, and we always have full admin. The community has full admin access rights to those lists because there has been some instances in the past where we've lost access. But currently, the main keys are being held by the Kubernetes steering committee. If you have any questions, feel free to drop them either in the Slack or, you can respond to the mail that'll be sent out later. And I guess that's it when it comes to announcements. Later this week, if I remember correctly, it's planned for December 11th, and I haven't seen any announcements for delays yet. Cube 132 should be released. So with that out of the way, I can give the voice to Philip, and Philip will provide us with an update on the evacuation API.
Yeah, so we discussed this in SIG Apps a couple of meetings back, and we were mainly interested in alternatives compared to the evacuation API, which was renamed to eviction request API, which flows better with today's other like documentation and eviction itself. So one of the main proposals voiced by Ravi that it would be nice to extend the eviction API, the imperative eviction API, which is which could be we could like extend it with a set of extenders. That would be basically like API calls to other services or components that would basically tell us more about how the request is or how the eviction itself should resolve. So we had a couple of discussions regarding that since. One of the main ones was in the SIG Arch call, which is also linked. And basically we run into a couple of issues. I mean that people from SIG Arch were not very supportive of this solution, mainly because of the scaling issues. I mean, like the time it could take to make the request itself, and authentication issues, and the like the chain of trust for this for these extenders, and it could cause issues down the road. So yeah, and besides that, I made an update to the CAP that, as I said, it's renamed to eviction requests, and the other like the API mentions of like we also renamed the evacuator to interceptor. And one of the main changes is also that we do not expect the pod to be deleted. So we just are interested in the pod termination. So it would flow nicely with other scenarios when the pod restart policy allows it. Then we could actually end up with the pod in the succeeded or failed state, and would basically use it for debugging or like capturing other information after the pod has terminated. And this could be also used in other termination scenarios. For example, in the kubelet, when they actually want to terminate the pods but not delete them. And yeah, one of the changes was also the name of the eviction request. So like I like to reiterate, the main proposal of this API is to actually allow making the eviction declaratively. So each eviction when it's created, or the eviction request when it's created, it does not resolve to immediate pod termination or deletion. And we basically give a chance to a set of interceptors to actually intercept this eviction and make like or do another logic before that and decide how in what way the pod will be terminated. And this is done by annotating a set of pods with these interceptors. So you would add it to your application, and when the pod is evicted by the eviction request, we would wait for the interceptor to observe the API type or the API object, and then it would report back that it captured the eviction request and would then reconcile the status of the request until it is done, and either it terminates the pod or passes it to another interceptor. So there can be like a chain of interceptors, and if neither of the interceptors terminate the pod, we would fall back to the current imperative eviction API, where we would try to evict the pod by calling the API server on the eviction endpoint. And this would also could bounce because of the PDBs. So like one other scenario I have added to the CAP is also like this generic descheduling or downscaling scenario. Recently we had a discussion in one issue regarding the replica set, that people are not happy how actually the downscaling of replica set behaves. So if you have a huge replica set and it's downscaled by either way, by horizontal pod scale or manually, then it would basically indiscriminately, or there is a logic to it, but it's not sufficient, but it would shut down part of the application, part of the pods, and this would mean that the scheduling constraints would not be preserved. So once the downscaling is done, then for example the pods would prefer, for example, one zone to another, and either you would have a like this balanced application, or you would need to use another component, for example, like the descheduler, to actually, but then you would need to also disrupt the pods that had started meanwhile, and there would be like this extra time and extra resources needed to actually offload the application to preserve the scheduling constraints. So this, I mean, this scenario and And that the eviction request would be useful in this case, that we would not need to implement like very heavy logic in the replica set controller. And we would basically leave this or offload this logic to the actor doing the downscaling. They would first select the number of pods or select the exact set of pods they need to be downscaled. And so they would create an eviction request for them, and they would downscale the application. And by downscaling it, the replica set controller would just prefer the eviction requests, like the pods which are mapped to the eviction requests. So this way, the downscaling itself and the selection process can be done asynchronously. And I can imagine other downscaling scenarios. So like today in Kubernetes, like there is not a very big support for like downscaling the applications. And this is done mainly by by other projects or like externally by other actors. But I think this API could actually help like in the future to implement similar downscaling scenarios. Okay, I don't know who wants to go next. If somebody has a comments to the first area, which is the alternatives, or the second area, which is the details of the cap.
Does anyone have any questions to Philip? Okay, well, let's go with the alternatives because I left there some questions while reviewing the document earlier today.
Okay.
So you've listed several alternatives. One of them was talking about improving the PDB status or conditions and expanding what the PDB currently exposes and then tracking the information about eventual evictions in the PDB. I started wondering, rather than that, the idea of the extenders, but a different in a different way. I was actually thinking about decoupling the entire eviction request API from the core kube by improving the current PDB information that we expose with much more detailed information about the status of what's going on with the PDB, whether that will be information about, oh, we cannot progress because the current PDB prevents the progress. And currently, if you do so and you don't explicitly ignore the PDBs, the drain logic will basically wait and retry every 5 seconds. I don't know why we're waiting specifically 5 seconds and not something longer, but doesn't matter. I started wondering maybe we could improve that kind of information in a PDB and then the users or the application owners could then watch their own PDBs or the entire set of PDBs in a particular namespace on or in the entire cluster, depending on whatever the requirement is. And they could be separately track the information about the entire eviction process, which would basically over time unblock the PDB. One of the use cases where you were talking about was either HPA or you have an application which was using just a single instance. In both of the cases, the problem is that you're only running one part of your application. And upon noticing that your PDB is blocking the application, you would be able to scale up the application, which would unblock the PDB from being stuck at one required pod, and the entire process could proceed. Similarly, it should smoothly apply to the other use cases when I was going through them while reading the document. And I haven't seen any such alternative which would be something along those lines. And that would also be improving the current PDB, because if I remember correctly, the part of the document where you're explicitly listing the issues with PDBs, at least 3 or 4 um, issues explicitly called out in that document, and I would have to open it up where that particular change was explained. 3 or 4 of them were explicitly problems with PDB that people have. Oh yeah, I think this is the list of PDBs. I'm pretty sure 3 or 4, maybe even a little bit longer, could be easily addressed and should be addressed with a little bit of tweaks in how we present the status. So that's what I wanted to say. I left a couple additional comments in a similar vein throughout the entire document, and I'll give voice to Ravi because I see he has his hand up.
Yeah, I think I have thoughts on similar vein. I think at a high level, we know that extending PDB is okay, but the challenge that the SIG Arch has presented to us is we do not want to use extender mechanisms, right? But that doesn't mean that we can enhance the status of the PDB or add new fields to PDB to make sure that that some of the existing problems that we have can be solved. Like for example, if we are continuously trying for every 5 seconds, can we have some sort of policy within the spec which says that start after some time? Like if the draining is blocked, can we have some policy in PDB which says that this is going to be an expirable PDB and it would not be honored after X amount of time? So those are like policy changes that we can make instead of going the extender route, and that might solve some of the problems that we have is what I'm thinking of. Does that make sense? Or
Yeah, I mean, the biggest issue that I'm seeing currently with this proposal and the declarative note, and it's, if I remember correctly, it's also in a similar vein on what we've heard in the SIG architecture call and in the previous SIG apps meetings, is basically the introduction of entirely new API has several downsides, and aside from just the implementation part, the actual path towards people adopting entirely the new solution and the amount of changes that are required across the entire system to implement it is a little bit of overwhelming. That's why I'm personally still leaning towards improving PDBs, and eventually the mechanism for coordinating any kind of eviction should be handled outside of the system, primarily because the majority of those evacuations will be very tightly coupled with the application itself that you're trying to evict, and that basically means the best and probably the simplest solution would be to expose as much information as we can to allow users to write their own eviction mechanism through PDBs, and improving the PDBs. I don't want to. We already have them, and there's multiple people who are using PDBs and are happy with their use cases. So we just need to make sure that the current use cases are continue to work as they were, and then just figure out a way to address those couple use cases where people were able to somewhat overuse or not necessarily use the PDBs as they were originally targeted at. Go ahead, Philip.
Okay, so yeah, I would like to comment on the extending the status of the PDB. I think there are a couple of issues there. So, like besides the, I mean, for example, when we look at the, as I said before about the replica set downscaling problem, there is actually like a similar alternative today, which is called pod deletion cost annotation. And even though it can be used in a way that it downscales the replica set, people have like problems with using this annotation, mainly the scalability issues, that if you have a huge replica set, you need to update the annotation of each pod, and you need to do it fairly often because you actually don't know when the downscaling happens. I mean, I think this is like in a way, this is a similar problem that we are trying to solve with this PDB status. So we would have to exhaustively update the PDBs, and we don't know like what's the how many underlying pods we have, and how many actual actors are there who would like to reconcile this information. So you would basically have people racing for updating the status, and this could, like, without any coordination, because there is no built-in coordination in the PDBs, they could override the status and could actually lose a couple of or some part of the information. And so like in some cases this could work, as Matej said, like when you would say that this PDB is blocking, for example, in this case with the single replica, that we would give this additional information, but it would not work in other cases. Yeah, for example, the selective downscaling. So because we cannot actually scale the status to the number of pods we have in the system, and like what is their status, and what is their actual like what part of life cycle in the termination they are in. Yeah, that's
Okay, so to address a couple of the issues that were mentioned, the pod deletion cost issue, especially with regards to downscaling replica set, the information that are in that particular issue are very minimal with regards to actual performance issues. I believe I pointed to one of the potential approaches about making sure that the distribution of the costs is sufficient enough that not that many updates of the pod deletion costs are required would be one approach. And probably a couple similar approaches could be used to make sure that the actual pod updates are not the bottleneck. Although I haven't seen any particular proof that we have a performance issue when updating those pod deletion costs. I haven't seen a concrete proof where that was laid out, only just speculation around that this could be problematic. When it comes to coordinating the PDB status with an external evacuation system, my goal was not to reflect the information and track the progress of the evacuation within the PDB, but rather the PDB would be just a window into the Kubernetes system about a particular PDB. And in a similar fashion as you're writing a controller, which is, I don't know, watching your particular CRD or watching a deployment, you would write a evacuation controller, which would be logging into the PDB. Where the information on or how the coordination about the actual order or progress of the actual eviction would happen would be tracked in a separate system, which could either be exposing that information either through CRD or something like that. I would not expect the PDB to be the central place for that kind of information. It would only be responsible to provide updates and provide like a window into what's going on inside of the system. That was roughly what I was considering as an option. Yeah, go ahead, Philip.
So yeah, so if we use this case where we put just like some flag or some low amount of information, then I think the main issue that's it's like hard to reason about, like in the Kubernetes components, for example, when we are talking about integrating this with a horizontal pod autoscaler or the replica set or even other components like the descheduler, then we wouldn't actually not have the enough information to have like exactly to have like an API to resolve the progress of the pod termination of the whole application. Then I can think of other two issues. One is that like not all pods are covered by a PDB, so people have expressed like a wish to actually use this in applications where you are just downscaling or terminating pods. And the second issue is that yeah, there's the same issue as I said before, like the need of permanent updates, and basically the PDB itself does not like when the eviction request is fired, it does not have the latest information. So yeah, that's all.
Ravi, go ahead.
Yeah, I think I could be wrong here, but I think we are combining two different things, right? I mean, the scale down within the replica set controller, how it is doing it versus how PDB wants to do it. Like if I'm all in for having some sort of specification within either via annotation or some field within PDB which says that this is how I want to do it, and this is the reason for doing it because you have said so. But I think in general, I'm okay with PDB doing the thing or PDB controller doing the thing, but the logic of how we want to define the order when we are actually deleting pods and all those things, that should actually come from the user. And there could be an external controller, especially for the workload, says that this is the order I want you to delete the pods, or this is how I want pods to be downscaled. That logic should still be with the user, and there should be a way to expose it via the PDB or via the replica set controller is what I think I'm trying to say, that if at all it makes sense.
Yeah, go ahead, Philip.
So yeah, choosing like what pods in what waves like this should be downscale. This is one of like the means is in the eviction request that the users can exactly specify, like by adding interceptors, they can specify this custom logic. So and have a way to control it. So I mean I actually don't see how like what is the big like what's actually the value of adding this to the PDB controller? What would the controller do? I mean, if you want to do this today, you can add a simple condition on the PDB, and you could actually coordinate your solution regarding that. So yeah, that's all.
And you think that is wrong, like enhancing PDB with a way to do it instead of writing new API? I think that's the question that
no, I don't mean it's wrong. I mean just the number of
you think
users
it's going to be complicated?
I mean the number of users is much lower because you are just tailoring the condition to your application. But what that means to you, but that does not like give like a meaningful way of describing the state or the future state of the pod.
I think what I'm saying is how the downscaling order should happen should still be with the user, and the user should specify it. And PDB would actually say that since you have specified it, or the PDB controller would say, since you have specified it, this is the order that I'm going to do the downscaling. Or like say, for example, there are like five pods in a particular replica set, or like in a stateful set. And there is one particular replica that we want to have running or taken down at last. The end user is going to specify by putting some condition on the pod object, on that particular pod object, saying that this has got the highest priority or highest weight that has to be taken down. The PDB controller would actually look at the policy specified, which says that honor weights or something like that. And based on that weight, it is going to evict one of the pods. I think what I'm trying to say is decouple the logic of expressing how the user wants to do it from how it is actually getting implemented. And that implementation can be owned by individual workload controller that the customer is going to write. The PDB is just going to be a place to express that policy, saying that, hey, I'm going to honor these weights. And how the weight is defined, it is something that the end user can actually specify the way he wants to.
Yeah, so
Yeah, go ahead, Phil.
So I think that's not like the PDB responsibility. Like the downscaling itself, it's up to each controller, which there are many of, and we don't know. Like you actually, as a PDB, you don't know what controller is beneath, and so like stateful set bits will downscale in a different way than replica set or some CRD.
I think the example that I gave is most likely related to how we want to specify the order when we are doing an eviction. And the underlying controller, I'm just giving you an example of how we can do this. It's not specific to downscaling that I'm talking about. I'm just in general talking about how we can enhance the PDB spec.
But what is the value having it in the PDB spec if we don't know like the application?
The end user knows the application, right? And they're going to specify that this is the order that I want to do the downscaling, or sorry, this is the order that I want to do the eviction.
But they would specify it better in the, like, for example, in the stateful set spec.
The stateful set spec is going to treat every pod similarly, right? It should not care about like which, I mean, at max, I think it looks at the ordered index. Or are you saying that you want to enhance that stateful?
I mean, I'm trying to understand like what is the value of specifying this in a PDB.
No, I think the example that I gave could be wrong, but the overall point that I'm trying to make is the downscaling logic or the eviction logic. If we can have some policy specified within the spec, and how that actually gets implemented could be outside of how the user wants to do. That might be a good like middle ground.
But I mean, there is like the disconnect. Like, you have the actor who is doing the eviction, and then you have the application
specifying that eviction.
And then you have also the owner of the application, and you have to communicate somehow how. But I mean, even the downscaling itself, like there is, again, I think it's a bit problematic to actually have a like, because this changes over the like every second. You need to update the constraints of like how many pods are running in what kind of cluster.
So to be clear, this changes. Who is going to specify that the order of the pod or the order of downscaling? Like, who's going to specify it? It still has to be the end user, right? Or are you saying that Kubernetes should actually make that call?
No, I mean, because like the downscaling itself, like, it's a complicated problem, because you have a few other components, for example, the scheduler, and you have many strategies how to downscale the application. And this is dynamic. So actually, it's very hard to predict, because what we are trying to do is to put into the status what will be like the future future termination scenario. And this is like very hard to predict and implement, and actually to set and abide by. And so like because
and
we
I
are
think that is the reason we should not do it, is what I'm trying to say.
Yeah, roughly the idea is that you're trying to describe a very application-specific process of managing the application. And in the majority of cases, a lot of that management that we're talking about and those issues that are being pointed in this document are often handling some edge cases or specific uses of an application, whether that's a single pod application using a PDB, or you mentioned that there are applications that are not using PDB. You don't have guarantees that once you introduce entirely new API, that people will start using new APIs to protect their application when they are already not using even the limited API that exists today in which is basically the PDB. And so my biggest concern is both the scope of the changes and how much it actually has to go through the entire cube to make sure that all the possible edge cases, which again are very specific to the application, are being handled inside of the cube rather than just providing a window into the disruptions through a PDB status, and then users or application owners could write their own logic around that window, where we would expose those additional information, which would allow them to manage the process. That's why I'm a little bit hesitant on this entire API being introduced, and yet the entire logic will be still handled outside of the cube, which theoretically isn't that much different from what people are using today with the validation webhooks, which the only difference is that they don't have that additional information exposed anywhere there, where we could fix it and also address the problem that only cluster admins can implement admission webhooks. Whereas if we would expose those additional information through a status of a PDB, that information is then available to every single user of system, every single owner of a PDB, to do with that information whatever they please and react to eventual application. Because as I'm reading this document, the majority of the cases is about, I want to have an information point where I could read the state of the system, especially around disruptions. And that already exists as a PDB. The only difference is that we don't expose much more detailed information about the process and the progress of the PDB as Cube is seeing it. And that information exists. It's just not exposed. That's why I'm leaning towards adding or expanding that information available, and then building eventual evacuation outside of the core.
Yeah, so
Yeah. Go ahead.
I mean, yeah, we are picking a couple of issues that are present today in the CAP, but what I have talked about with people, like there is, I think it's not like it's not very it's not like very edge casey, because we want to solve mainly the issues regarding either the pod autoscaling or node autoscaling, which this has also other features features that we could use in the node maintenance API. And for example, so I think I have a different viewpoint that I do not think like this has a very low impact, because first, like, yeah, as you said, we can offload some of the logics to the outside of the Kubernetes and they implement the eviction themselves. But we can offer this, for example, in the horizontal pod auto scaling, which would be very beneficial to a lot of applications. And also, like when we dive into the cluster auto scaling scenario, there are like a lot of solutions that have like a set of flags how to actually downscale a node or drain a node, and this is like very finicky. So like it would be better if we actually started moving this responsibility of terminating the pods, if we would start to move them to the applications themselves, so they could actually decide like in what way the pods will be terminated.
Right, but that what I just explained, how the process could be done through an external actor, which is driven by additional information that we expose in PDB, that doesn't contradict what you just said.
No, I mean this. I still do not see like a very compelling solution there, because like just for start, like the mapping is wrong. So you have on one side you have like n pods, then you have one PDB, and then you have n actors which are either trying to either evict the pod, or try to actually prevent or have some better implementation of the eviction. Yeah, Ravi.
And I think the question is more on the lines of if the user specifies that this is the order that we want to go ahead and do the eviction, is that what you want the PDB controller to implement, or you want it to be much more specific in the way how it does implementation? Because that might solve the use case of that particular user, but it may not be generic enough for every user.
Yeah, I mean, it will probably, like, because like if we just try to focus on one example, for example, the rescheduling or downscaling, then we might try to find some solution, but there is like n scenarios where we cannot know all of them, and actually only the users know these scenarios, and it's very hard to predict and like box it into the PDB API.
No, we should not put it, right? So the downscaling, say if it is controller specific, it should be within the controller specific, right? But the point I think that Mache or I, like we are trying to make is, if the end user specifies or has knowledge, or if that application has got knowledge of how to do the downscaling, the core controller should still do the downscaling, but the order should be specified by the user. And there should be a way to specify in the spec or within the policy saying that this is the order that you need to honor. And again, what I'm trying to say is the API should do just the specification and the implementation, but the actual code which actually says this is the order that I want to live, downscaling, that should be within the realm of application, is what I'm trying to say.
Yeah, but I mean, like in this case, like the responsibility lies in a different place. So, like
the responsibility of specifically setting the weight of how the downscaling should happen would be with the end user.
No, I mean, like as I said before, like the downscaling problem is like a very like a rich set of constraints that needs to be resolved, and you need to do it just in time when the eviction happens. And but the user who says that they want to downscale the application in this way is a different user to the controller, like managing the pods. So for example, the replica set, and you need to communicate just in time this way of downscaling to the controller.
Correct. And you think that would be racy? Is that the concern there? Because I think it's a clear separation of concerns, right? So we are saying that we would do the like the controller is going to do a downscaling, but you define the policy. The end user who understands the application is going to have those policies set.
But you don't know the policy before, so you know it
But the
just
application knows
in
it.
time. No, they
Yeah,
don't
so
know it. They know it only when you just evict the pods, and each pod when it's evicted, it affects like the state of the
correct. And we are
cluster.
going to communicate that status, and the end user is going to specify that, oh, I looked at the status now, I cannot downscale one more pod again.
No,
You
I
think
mean,
that
but
would be racy? Is that
yeah, like it's racy, but like why is it important to communicate it through a PDB, this scenario? And also,
I'm not talking about PDB. I think we are just talking about the API, like how the API should have a status for the communication to happen between the entity which wants the downscaling to happen, or the actor who wants to do the downscaling, and the actual downscaling which we are doing within the core control.
yeah, so if we do not talk about the PDB, like you could do it through the eviction request as is in the cap. Like I have outlined the scenarios there.
True, but that's not enhancing the existing PDB, right? It's like or enhancing any of the existing APIs. It's like creating a new API altogether.
Yeah, but I mean, I see it. I see like very difficult or impossible to actually implement it through a PDB.
Okay, let's try to look at those challenges. Perhaps we can have a discussion on those
Yeah, I
challenges.
mean, like
If they are just
first challenge is just that not all applications use a PDB. So like when you look at it like from the like scaling perspective, or for example, the horizontal pod autoscaler, you want these behaviors to actually have a better scaling of the application, either downscaling or upscaling. You actually do not care if the application is governed by PDB, and you could improve these behaviors for existing applications who do not have a need for a PDB or historically didn't have it.
and
Or
say if you do not want to, I'm sorry to interrupt you here, but say if you do not want to create a new API, which API in Kubernetes would you touch to specify this?
yeah, that's like why I started the cap, because like the main like because we implement it through the eviction, and the eviction is imperative, and that's why it's hard to use. So that's I don't see like any like
You're saying
alternative.
that no, you're saying that PDBs are not used by certain applications. So there is no PDB in here. I think the question that you are asking is, say if applications are not covered by PDBs and they're just going to do the upscaling and downscaling, we do not have an API through which we can express how the downscaling should happen or how upscaling should happen. Is that right?
Yeah.
So you want to enhance the scale sub-resource? Is that what you are saying? Like say if we have something there, or you think that is not good enough?
No, not the scale sub-resource. That's
Or
also
like say, is there, why do you think the existing API is not good enough? Because you're like combining two different things, right? I mean, PDB is one thing, and if you're saying that the scale has got some issues, that is a different problem.
No, I mean, not just the scale. Like this is like concerning the whole descheduling topic. So we do not have like a good strategy in Kubernetes to actually terminate pods, and that's why this comes into play.
So that is a different problem, right? So like when you're talking about the descheduling, how the eviction should happen, and sorry, I think descheduler also uses eviction. So what is the strategy to actually properly scale down the application? Is that the problem that we are trying to solve when PDBs are not there?
Like there is there is a set of problems, but this is one of them. And like to touch on the descheduler, they actually so like there is an alternative. Like we have tried to implement this first. It was through the pod API to actually give hints in the pod API how the eviction should proceed or not. But there were a couple of issues there, and similar scenario, like or this scenario through the pod API through the annotations. Like the scheduler has recently implemented a cap where they are actually trying to do like the similar thing, but they have it in alpha, and they would like to move this also to the eviction request in beta. So they are just doing it as a proof of concept.
I have like some reservations there, but I'll let someone else speak because I think I've been talking like a lot. So I'll stop here. I'll pass the floor.
I have one question, one comment to close off the discussion because we're slowly running out of time. You've mentioned a couple of times that people are not using PDBs, which if you look at the PDB, it's a very simple primitive that already exists in Kube and has existed for multiple releases, which maybe not ideal, but it already provides some kind of guarantees around the availability of your application. And you're saying that people are not using PDBs. What is the chance that a mechanism much more sophisticated, much more performant, or in case of like much more feature rich, such as what you're describing in the eviction request API, what is your confidence that the people will start using the eviction API if they're not using something that already exists and is available?
Yeah, so I mean, like it would be good to start like with low-hanging fruit, which is because like basically this just enhances like this API is mainly, I think, the and like the reflection is on the eviction, not on the PDB. This is trying to replace the eviction itself, which is just the API call. And so since this builds on top of eviction, you can actually just replace your eviction call with just creating this object. So like the implementation part is not that difficult, and we can just I talked to like the people from the autoscaling community, and they said they would also like to use this API. So we could just add it to a couple of drainers, or even add an option to kubectl drain and have it on the like the requester side. So I think that's the adoption there is not difficult, and we could actually supply some like some nicer behaviors in the core itself. And for example, for the horizontal pod autoscaler, so the community, we don't know how much the community will adopt it, but we can give much nicer, for example, the autoscaling in just the Kubernetes core. And yeah, and so one of the also like features of this is that we could replace currently people that are using in many projects are using the validation webhooks, and basically I think it will be mainly hard to convince them to go away from these, but the new use cases or some slower adoption could occur, and this would give us better observability and control of the whole eviction.
Okay. With that, I think we can conclude our today's discussion. I invite everyone to check the documents that Philip linked in the agenda and leave your comments and the proposal. Thank you very much, everyone, for today. I want to say that's see you in 2 weeks, but I believe it's right. In 2 weeks, it'll be right around the corner from Christmas, and the majority of the folks will be out. So probably we'll see each other after New Year. So until then, thank you very much. See you all, folks.
Thank you. Bye.
Thanks.